Happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All righty. So today we're going to start a new chapter, and that is chapter 8. And we're going to be spending actually 2 class periods on section 8.2. So today is section 8.2, part 1. Okay. So I want to talk about people and birthdays. Let's say we had, 4 individuals. We have Jose, Mary, Sue, and let's see, Lewis. All right. So these are people. And over here, we're going to have birthdays. Jose's birthday is January 16th. All right. And Mary's birthday is May 7th. Sue's birthday is March 9th. And Luisa's birthday is also May 7th. Okay. So what we see here is an example of how birthdays can work. Everybody has one birthday. Nobody has more than one birthday, but you can have more than one person, in this case, 2 people with the same birthday. Okay. This is very much the way that something called a function works. Let me read to you from the textbook how it describes a function. It says this. It says a function, this is on page 614 of the textbook, in case you want to look it up. A function is a set of ordered pairs in which to each first component there corresponds exactly one second component. The set of the first components is called the domain of the function, and the set of the second components is called the range of the function. All right. So this is like input and output. For each member, let's see, how did it say it? In which each first component to each first component, so this would be the first component, there is exactly one second component. So each person has exactly one birthday. Now, Mary and Luis both have the same birthday, but each one goes to just one birthday. So this is how a function can work. You can't have something over here like Luis has a birthday on May 7th and on March 9th. That would violate how a function works. Okay, now we've got input and output, domain, range, x values, y values, cause, effect. These are all different ways of describing the same thing. Giovanni, did you go outside yesterday? Did you?
Yes, I did.
Okay, was it cold?
Yeah.
So you wore a coat?
No.
That's not working. Okay, but did you wear any warm clothes at all?
No.
Okay, fine. Let's say tomorrow you wake up and it's 20 degrees outside and it's snowing. Would you put a coat on to go outside?
No.
You wouldn't?
No, I love the cold. I would go
Okay.
outside in a tank top and it's snowing.
Okay, all right. Let's say it's 20 degrees below zero. You're in Antarctica. Then would you put on a coat?
Maybe.
Okay, you're just destroying my whole example here. Fine, you know what? I'm going to use myself here since there's just the two of us. All right. If it was cold outside, I'd put a coat on. So the cause would be the cold weather. The effect would be me putting a coat on. Or is it the other way around? I decide, you know, I'm going to put a coat on. I step outside and immediately the weather changes to being cold. Is that how it works?
Yes.
It does? Me putting on a coat would make the weather change?
Oh, no, my bad.
Okay, all right. So you've been outside without a coat too long. It's affected your thinking.
Yes.
But anyway, the idea is the cause would be the weather. The effect would be what you wear because of the weather, not the other way around. So the cause would be the input or the domain. The effect would be the output or the range. Okay, that's just all I'm trying to get across there. All right, now let's look at some examples to deal with domain and range. Let's say we have this set, of ordered pairs. So we've got 7, -1, -1, -1, -5, 3, and 8, -6. So the domain would be the X values, -5, -1, 7, and 8. The range would be the Y values, -1. Oops, I should have done them in order and I missed one here. It would be -6, -1, and 3. Okay, so the domain is all the X values of the ordered pairs. The range is all the Y values. Does that make sense? Hey, now we've got some more people, or maybe they were there all along. Okay. I could have asked them about wearing a coat, but I won't. All right, now, let's take a look at this situation. This is the inputs, 10, 20, and 30. And this is the outputs, 20, 40, and 60. 10 goes to 20, 20 goes to 40, 30 goes to 60. Does this describe a function? Is this situation a function?
Yes.
Yes, good. Okay. How about, so this is yes. How about this one? -4, -2, 0, and 6, 8, 10, 12. -4 goes to 6, 2 goes to 8, 0 goes to 10, and 0 goes to 12. How about this? Is this a function?
No.
No, because one input goes to more than one output. It could be an equation, but it's not a function. A function is an equation, but then has these special properties we've been looking at. Okay, let's see here. How about that? Is that a function?
Yes.
No,
Why not?
Oh, wait.
because X goes to multiple Y's.
Right, you've got one person with 5 birthdays. Lucky guy. Okay. How about this one? So this is a no. How about this one here? Is that a function?
No.
What?
Yes.
Yes. You've got quadruplets, 4 people with the same birthday. That's okay. You can have several inputs going to the same output, but you can't have one input going to more than one output. All right, now, functions have special notation. Y equals 2x plus 3. To write that using function notation, we'd say f of x equals 2x plus 3. So f of x is another name for y. But this symbol can be confusing. For instance, let's say I had a parentheses b. What would you think was happening there? What operation would you think was going on between a and b?
A times B.
Yeah, so the parentheses, you'd think it was multiplication, right? So this, or here, you'd think it was f times x, but it's not. Now, if you took Math 75 long ago, or if you dealt with percentage problems where it said 3 is what percent of 17? The word of translated into multiplication. So in some contexts, the word of translates to multiplication. This is f is a function of x, but the shortcut way we say it is we say f of x. So again, f of x, you might think that was f times x. So it looks like multiplication, it sounds like multiplication, but it's not. It's just a single symbol that's a fancy function notation symbol for writing y. Okay, so it's not f times x, it's f of x, it's another name for y. Now let's go back to this. Y equals 2x plus 3. And let's say we have a table, and we're going to complete some table values here. We'll go -2, -1, 0, and 1. And it will go on to 2, okay? How would you find the corresponding y values? What would you do?
Plug in the x's.
Yeah, so you'd say -2 goes in there. You'd have what? 2 times -2 plus 3, which is -4 plus 3, which is -1, right? So for y equals 2x plus 3, when x is -2, y is -1. And so on, you'd say, oh, when x is -1, 2 times -1 plus 3 is -2 plus 3, which is +1. When x is 0, 2 times 0 plus 3 equals 0 plus 3, which is 3. And 2 times 1 plus 3 is 2 plus 3, which is 5. And 2 times 2 plus 3 is 4 plus 3, which is 7, right? So we go through, plug in the x value in the place of x on the right side of the equation, and calculate the y values. Any questions about that? Okay, now, let's say we have this. We have f of x equals 2x plus 3. And we want to find f of -2, f of -1, f of 0, f of 1, and f of 2. F of -2. What that's saying is, for this function, f of x, evaluate it, find out what y is when x is -2. How do you do that? The same way you did it over here. We take the -2 and put it right there. So this is going to be 2 times -2 plus 3, which is -1. This is going to be 2 times -1 plus 3, which is 1. And 2 times 0 plus 3, which is 3. And this is going to be 5, and this is going to be 7. So this is the same. So let's see. -2, -1 is the same thing as the ordered pair, -2, -1. And in function notation, it would be f of -2 equals -1. So that's the function notation way of writing this ordered pair or this table. Okay, so the input is on the inside and the output is on the outside. The stuff you put inside would be the domain. The stuff that results is the range. Domain would be the X values that work. Range would be the Y values that work. Okay. Now, let's say we've got the following function. F of X equals 3X minus 5. They want us to find F of 3 and F of -1. So how would you go about finding F of 3?
Plugging the 3 into the X spot. The
Yeah.
one.
Yeah, put the 3 in the place of X. So you'd have 3 times 3 minus 5. 9 minus 5 is 4. So F of 3 equals 4. And that corresponds to the ordered pair 3, 4. Just as this is a point on the graph, that would also be a point on a graph if you were going to graph F of X equals 3X minus 5. Okay. So it's same old stuff, new notation. F of -1, 3 times -1 minus 5, -3 minus 5, -8. F of -1 equals -8. That corresponds to that ordered pair.
I might be a little bit confused. The last slide, when we found F of X, the X and Y were switched around. Is it the same thing, or do you get my question?
What was the first thing you said?
So on the last slide, when we found F of X, the X and Y were switched around. So like when you said when you plug it on the right side, it becomes the X and the Y. I might have that confused on that.
Okay, is this the slide you're referring to?
Yes.
Now you said that the X and Y were switched around. I'm not, that's.
So on the left side, you said when we plug in the X for the equation, it's -2 and -1. So on the left side over here, on
There?
yes. So when we plug in the -2, it equals -2, and the Y is -1. Right?
Yes.
When we plugged it in, it was the Y was -2.
Ah, okay. No, it's not. And let's take a look at that. Okay. That is Y. But if I put that in, this is X, and the result is Y. So when I'm putting a 2 inside, I'm not replacing all of that with 2. I'm just saying, oh, we're going to deal with 2. 2 goes into the function, 7 comes out. So back here, these values that are in place of the X inside, those are still the X values.
Got it. Got it.
Okay, yeah, I'm glad you asked for clarification on that. Okay. Now, let's say we've got H of X equals, oh, I'm not using F of X anymore. What's with that? Well, just like typically we start off with variables X and Y when we deal with graphing and ordered pairs and stuff, but ultimately we can use any letters for, inputs and outputs. We start out with F of X for Y, but we can use other letters. For instance, let's say this was a business algebra class and we were talking about a profit function. That would be P of X. A cost function might be C of X. A revenue function might be, R of X. So it's not just limited to F of X. Okay, anyway, H of X equals 3 over X minus 4. Okay, what would H of 5 equal? Or just how would you find it?
Plug it in the 5 to the X.
Yeah, so you'd have 3 over 5 minus 4, which is 3 over 1, which is 3. So H of 5 equals 3. Okay with that? How about H of -2? So again, what's on the inside is the input. That's the X because it replaced X. So that goes in the place of X. So H of -2 equals -1/2. And this corresponds to the ordered pair -2, -1/2. And this corresponds to the ordered pair 5, 3. Okay. Inputs inside, outputs outside. X inside, Y outside. We okay? All right. H of X equals X squared plus X minus 2 divided by X squared minus 5X. We're going to find H of -2. So we're going to put -2 in the place of all the X's. It's X squared, so it's -2 the quantity squared, plus X, so plus -2, and then minus 2, over X squared, so -2 the quantity squared, minus 5 times -2. -2 the quantity squared is 4, plus -2 minus 2 would be 0. On the bottom, -2 the quantity squared is 4, minus 5 times -2 is plus 10. But what is 0 divided by 14?
0.
So H of -2 equals 0. All right. Now let's find, let's see, H of 5. Keep writing too big here. I have more room, so we'll say H of 2 equals 0. So H of 5 would be 5 squared plus 5 minus 2 over 5 squared minus 5 times 5. Okay, again, I'm putting 5 in the place of all the X's. Let's see, up on top, we've got what? 27 plus 5 is what? Oh, excuse me, 25 plus 5 is 30, minus 2 would be what, 28? And on the bottom, we've got what, 25 minus 25. What's 25 minus 25?
0.
What's 28 divided by 0?
Undefined or?
Good, undefined. Now, 5 as an input does not produce a real output. So 5 is not in the domain of the function. It is not an acceptable input because it does not produce a real output. Okay? When I was a kid, my mother had this meat grinder, and it was made out of pot metal. And I don't know if you're familiar with pot metal, but it's pretty cheap. And like if you ever try to weld something with pot metal, it just kind of blows it all away and it doesn't work. But we had this meat grinder, and my brother put a rock in the meat grinder and turned the crank. What do you think happened?
It broke.
Yeah, it wasn't a rock grinder, it was a meat grinder. And don't tell my brother I said this because it's not really true. We did have a meat grinder, but he didn't put a rock in it. But my point is this: if you put something in that doesn't belong there, you get bad results. Okay, so when we put 5 into H of X, we got bad results. We got undefined. Therefore, 5 is not in the domain of the function. Okay, we're going to expand on that idea a bit here. Let's see. But first, this. Let's say we've got g of x equals 2x. All right. How would you find g of 1?
Multiplying the 2 by the 1.
Yeah, you'd put 1 in the place of x, right? How would you find g of 1.5? What would you do?
Same thing, right?
Okay, good. And that's the answer I was wanting. Same thing. How would you find g of star?
Same thing.
Which would give you 2 star, right?
Yeah.
Okay, now, how would you find g of w?
same way.
Yeah. What was the hesitation? You were doing great. You overthought it. How about this? What about g of w plus 1?
Same thing.
So you'd have 2 times the quantity w plus 1, which would ultimately give you 2w plus 2 when you distribute it, right? Okay with that? In fact, this in general would be g of that equals 2 times whatever. So whatever goes here goes there. And then you multiply it out. All right? Don't overthink it. It's not that complicated. Now, suppose we've got f of x equals negative 2x plus 5. And then it says, for what value, so for what value of x does function f have the given value? And it says f of x equals 5. Okay, this is sort of playing Jeopardy. They're giving you the answer and asking you what's the question. So the output is 5. What's the input that produces that? Okay, let's come back to this. I want to look at something else. Y equals negative 2x plus 5. And let's say we've got this table and it looks like this. Okay, so we've got y equals 2x or negative 2x plus 5. We know what y is. How do we find x? What do we do?
Plug in the y.
Plug in the y. What do you mean plug in the y?
Put the 5 on the left
Okay,
side.
so the 5 goes in the place of y, right? You'd have 5 equals negative 2x plus 5. Okay. Then you'd what? Subtract 5, 0 equals negative 2x, divide by negative 2, and you'd get x equals 0, right?
Yes.
Okay, now let's go back here. For what value of x does function f have the given value? It's the same question. They're saying what goes in here that gives us a 5 for y. So what are we going to do? We're going to put the 5 up there and go 5 equals negative 2x plus 5, and we get the same answer we found there. So therefore, x equals 0 is what we're looking for, which means f of 0 equals 5. Okay? So here, they're giving you the end result. They're saying, what do you have to put in to get that end result? So this is where you'd put the end result. It's not f of 5, it's f of x. The whole thing becomes 5. Okay? We'll see. We'll see. That tends to be a confusing point, but we'll see how it goes. Let's do another one of those. Let's say I've got f of x equals 3/2 x minus 2. For what value of x does the function have the given value f of x equals 2/3? So this is going to go in the place of that. We're going to get 2/3 equals 3/2 x minus 2. Do you see what I did there? Again, let's see. I'm going to add 2 to both sides. 2 and 2/3 equals 3/2 x. 2 and 2/3 would be 8/3 equals 3/2 x. Multiply both sides by 2/3. X equals 16/9. So f of 16/9 equals 2/3. For what value of x does f of x equals 2/3? 16/9. All right with that? Okay. I've got a question for you. Did any of you have trouble observing on YouTube the video that was the chapter 7 review?
Not that I
Nobody had any? Okay. I got an email from YouTube yesterday saying that because of some inappropriate content on that video, they were putting a restriction on it, and I tried to contact them and couldn't get through. And I thought, what was on there that was, but it said something about people would be restricted. They'd either have to be signed in or over 18 or something, but nobody had any issues. So
No.
maybe
it was fun.
maybe it's that false news stuff. Anyway, okay. All right, just wanted to make sure there. I thought maybe it was because, it was graphic, all those drawings. Sorry. Well, that's all I've got for you for today. So I am gonna stop the recording and